So we have to have any point to start. So I'm going to just go with 1, 5, 3. Then for our direction vector, until you've done a lot of these, I always just think, just draw P and Q, think of your origin, and think, if I wanted to go from P to Q as my direction, then I'm going to have to go negative P and add Q, which is the same as Q minus P. So 2, 0, negative 4, minus 1, 5, 3, 1, negative 5, negative 7. Now the question is, does this point, negative 1, 3, 5, lie on the line? And what we could do is we could look back at this and we could write out our parametric equations. We have x is equal to 1 plus t. We got y is going to be equal to 5 minus 5t. And we've got z is equal to 3 minus 7t. So what this is really asking us is when they're asking us if a point exists. It used to be with y equals mx plus b, if that point was on the line, you plugged it in, and it made the statement either true or false. We do a similar thing here in that we plug it in, and then we find out what the t-value would have to be if we plug that in. And if the t-value is the same for the x, the y, and the z coordinate, then we know that that point could be gotten by moving along the line in that direction. If the t-value is different for any one of these coordinates, then we're going to find out that that point isn't on the line. So let's start with the first one. If I plug in negative 1 into my x coordinate, this is going to tell me that t is supposed to be equal to negative 2. If I plug in 3, I get t is 2 over 5. At this point, I already know that this is not on the line. I don't even have to keep going. I can say no, because my t-value isn't the same. What about the third one? Just for curiosity's sake, that's going to be 2 over negative 7. So there isn't one t-value that would get me from my starting point along that direction vector to this point. So this point is not on the line. What about this one? Probably guess is if a teacher's putting two examples that are same, one would be on the line and one would be not on the line. Probably. Unless that teacher made a mistake in their notes, and you could get another example where it's not on the line. It's looking good. Oh, so close. Oh, so disappointing. So the answer again is no. All three of them would have to be 2 in order for it to work. It would, yeah, you could, if you went to the Cartesian one, then you would have an equation. Now the problem with three-dimensional ones is you'd have 3 things that were equal. So you'd have, once you have that though, you could plug in your x, your y, and your z into all 3, and then all 3 would have to be equal for it to work. But generally, to get to the Cartesian one, you have to do this first anyway, so it's just as easy to plug this in.